going to the basic idea, you have to understand a few things here. First is this. Let's go back again to the idea of state of stress. Everybody knows what the plane stress is, or you forgot about it, or plane stress. Do you remember, anybody have heard the plane stress? In my class, in ME 218, we did it, but everybody remembered that? Probably not, but that's okay. But I'm going to mention it one more time what it is. What we are doing here, which is very essential to all the stress analysis, is this. If we are looking at the body is 3D. Is that correct or not? And when we look at it, we may or may not have sigma x and sigma y. Is that correct or not? Then we may or may not have tau xy and tau xy. But if we go in the general, you don't need that one. If you go in the general state of stress, and you will see that we may or may not have sigma z as well. Is that correct or not? Yes. And then not even that, we had two more shear, which I'm not going to put that. Remember the way we subscript this is xy. It means this is in a plane perpendicular to the x direction. This is in the plane perpendicular to the y direction. So we call that tau x going, Yes, that the plane, yeah, this is in the plane perpendicular to x, but it's going in the y direction. This one is a plane perpendicular to the y, but it's going in the x direction. That one is tau yx, the other one tau xy. They are equal. Is that correct or not? Then this was, we had here three stresses, and we had three shear. Is that correct? Because 2 of 2, they were equal. Yes, this is the general state of stress. However, the way we design it, the object still is 3D. But we are assuming everything is on the surface. Everybody understand that? I have brought this many times. When this is a shaft or a beam, this is a 3D body, yes or no? However, when I look at this part, looks like a plate. Is that correct? So we call it plane stress. It has sigma x, sigma y, sigma x, sigma y, but nothing coming from the z direction. Therefore, remember that all your stress analysis, undergraduate stress analysis, or on the basis of sigma z, must be equal to 0. So this was 0. Also, these two were 0, which I'm going to put it here, but that's not for tau x z equal to tau zx, which is this one of this stuff, must be equal to 0. Tau yz equal to tau zy must be equal to 0, but I don't care about that much as you have to concentrate on that much for today's discussion. So in other words, there is no stress on this surface as you see it here. Is that correct or not? Yes? You pull it, twist it, whatever you do to this, nothing coming this way. It's everything coming either this way or that way. Even if you put pressure inside, this is going to go this way and that way. Yes or no? Therefore, nothing from the z side. That's why we call. You don't see it, but you have to understand that everything you do in ME 218 and in ME 219 are plane stress. Everybody else, let's call this one. Put this one plane. I'll put it in capital, plane stress. This is very important for this chapter because otherwise we cannot follow what we are doing here. So, and I don't care about that. Let's put that in perspective. When we do that, this is a plane stress. Is that correct or not? Yep. And as the result, this is why we don't show it in cubic. Many times we show that as a square. You have done it. 99% of the time you show that as square. That because it's plane stress. Everybody understands. The depth doesn't matter. Or we are on the surface as you see it. This surface, that's it. Correct or not? Therefore, however, what happened to epsilon z? Is there epsilon there or not? Yes. Yes, of course it is. No, you cannot go to sleep on me, my friend. Is that correct or not? Yes? Yeah, I almost lost you. Okay. All right. So there, I can see it in your eyes, whether you are following me, you are understanding it, or you say, okay, let it go. I'll listen to next sentence, but please be careful. You see, I'm watching you. All right. So therefore, that is very important to recognize for future because you are pulling a plate this way and you are pulling it that way. Obviously, the third dimension should become smaller. Based on what? Based on? Not based, because of what we learned in ME218, which is that you are talking about the general theory, that because of the Hooke's law. Is that correct or not? Remember the Hooke's law? Now you have to study that. I asked you to study that. The Hooke's law are the following. Epsilon x equal to what? Epsilon x is not due to sigma x only. Epsilon x is due to the sigma x, sigma y, and sigma z. So epsilon x equal to sigma x over E, which is the result of the Hooke's law, the graph that we draw in ME218. Then later on, when the Poisson ratio came into the picture, because of the Poisson ratio, when we put it this way, the other side become smaller, yes or no? So we said minus nu sigma y over E minus nu sigma z over E. This is the generalized Hooke's law for all three x, y, and z. Then epsilon y equal to minus nu sigma x over E plus sigma y over E minus nu sigma z over E. However, in this plane stress radio, I assume sigma z is 0. Is that correct or not? Since sigma z generally, not always, when I put it under the water, sigma z was not 0. Is that correct or not? Or I put it in the sky, sigma z was not equal to. But generally for plane stress, which your problem falls into that category, this one is 0. Therefore, I even don't put epsilon, the other sigma there. However, you can add that one. And then epsilon z become equal to what? Epsilon z become effect of this tension and this tension. The other side should get smaller and smaller, minus nu sigma x over E minus nu sigma y over E. As you see, if these two are tension, this become smaller. Is that correct? Or reverse, if I take a plane, push it this way, the other side gets a little bit large. But epsilon z, therefore, is not equal to 0. Now, what is involved here? I said it earlier, that we have to start now. Now, what did we do after that? This is what the handout is all about. If you look at your handout, you see what I have put it here as a background, because sometimes I want to remind you, you go back again, take a look. Okay, what did we do? Why did we do all of this sort of thing? The detail of it is not important, this page. That's the review. This is the type of problem I gave to all. This problem were part of ME218, my classes. You have it or you don't have it. That's for review. This is the lecture. Is that correct or not? This was, say, 219, correct? Knowing that you have gone through that in ME218. Now, if you have not gone through that or you don't remember it, you may want to take a small look at it. Is that correct or not? However, listen to me carefully. This is much more important. So this is the relationship. These are what? These are the normal. What do we call this one? What are the normal strain? Is that correct or not? Or do we have a shear strain due to the top? Yes? Remember those? What is that equation? Gamma xy equal to what? Tau xy divided by modulus of rigidity. Yes or no? Correct? That's what I asked you over the weekend to study this a little bit. I don't know whether you did or not. Otherwise, the lecture becomes much more difficult to understand. Is that correct or not? We have three normal strain, epsilon x, epsilon y, epsilon z, which depend on sigma x, sigma y, and sigma z. And we have also three shear strain, which is angular deformation. Remember the angular deformation, the angle becomes smaller, larger. You have some problem in ME218 in that regard, yes or no? Therefore, one was like that. The other two become irrelevant because they are, in this time, we are not considering them because it's 0. Gamma xz equal to tau xz divided by modulus of rigidity, and the other one. But I don't put the other one in because there are three of them here, three of them there. They are not related to sigma, they are related to the tau. We have 3 tau, so we have 3 gamma as well. But the one that we are concerned is this one. Is that correct? Because that's the way we always start with the plane of x and y. I can call that plane also x and y, this plane x and y, that plane x and y. Is that correct or not? Yes? Because x and y is arbitrary. Nevertheless, that's the system. Is that correct or not? Now, what we want to do, as I said it earlier, we go there. Then what did we do with this? First of all, if I have sigma, can I calculate by epsilon? Look, if I give you sigma x, sigma y, tau xy, you can calculate epsilon x, epsilon y, and knowing what modulus elasticity and Poisson ratio is, and modulus of rigidity. By the way, there was another formula as refresher, your reminder. There is a relationship between E, G, and nu. Remember that equation? Or something like that. As long as you remember there is an equation, you don't have to remember the formula. That's I don't want, never, ever you remember the formula. You have to recall there is a relationship between these three. Is that correct? And that relationship, I put it here. G was equal to E times 2 times 1 plus nu. The reason I'm saying that in some homework they give you nu and G, you have to calculate E, or most of the time they give you E and G and you have to calculate the nu from that equation. So if you see a data is missing, that relationship help you to find the third term, which is usually the nu. Is that correct? Because E and G we can measure it in the lab, but nu we cannot measure it in the lab. Is that correct or not? Because when I want to measure the E, all I have to do to get the rod and put it under tension test, as you have done it, some of you in the lab. Anybody have taken the lab? Did you do the tensile test? Did you do the tensile test? Then you calculate the modulus of elasticity. If you twist it or torsion it, you can calculate modulus of rigidity. Actually, that's the first two tests that everybody runs in the lab to determine the E and the G. But nu is part of properties of material, and therefore that one you come to formulate it. Is that correct or not? Yes? Anyhow, so that's the relation. Now we want to do something else. So here, anytime I want to do that, I'm writing here. Now, this is the result. I have sigma x, sigma y, tau xy, and sigma z is equal to 0. Epsilon z is not equal to 0. Then I go through the process of the Morse circle to calculate what? To calculate the principal stresses, maximum everything, which again, I can use those equations to find the principal strain. That's not the point. Is that correct or not? Now we want to do something else. This time we want to, this is a plane stress, and we go to the process of the Morse circle. It took us a quarter and a half to do all of that. Is that correct or not? Now that we want to go from strain, it should not take us more than 1 class and a half to do everything, because we already know everything. Is that correct or not? This time we want to start from this point. Instead of sigma x in the testing, we are going to measure epsilon x. Is that correct or not? Yes? Then let's say that we want to measure epsilon y, yes or no? Then what do I need instead of tau? If I want to go from a stress to go to a strain, what do I need? I need gamma, that's right. So I need to give you gamma xy. So if I give you that, this becomes exactly similar to this. Is that correct? This is plane stress. This we are going to call it plane strain. Is that correct or not? Yeah, exactly similar, because I want to do exactly the same as we did before. Is that correct or not? Yes? Then what will happen? Look, I have to change all this, reverse everything. Is that correct or not? Then I have to say what? Epsilon z equal to 0 in order to match this. Is that, is that sigma z was equal, sigma become epsilon. Is that correct? How can I make epsilon z equal to 0? How can our object, which is under a stress or a strain in the x and y direction, you have seen that. That's what this review was all about. How can is this review that you see there? There are 2-3 problems related to this without you realizing. So I want you to take a look at it later on, the first 4 pages, ME 218 review. How do I make, you have seen it, think about it. How can you, see, if you have an object plate here, you are pushing it this way, you are pushing it this way. If this side gets larger or not, yes? How can I prevent this from moving? Put it between 2 rigid plates. Is that correct? It's exactly what we have to do. If I want this not to move in the other direction, I have to put it between 2 rigid plates. Is that correct? In the other class, I said it Oreo cookie. You see, that has to be a soft material between 2 harder material relatively. For example, if you have this soft material here, it's already broken. This soft material and this is hard, and I put another one here. When I pull it and push it this way, nothing happens in this direction. Is that correct or not? Therefore, when epsilon z equal to 0, sigma z, of course, will not be equal to
0, because you want to expand and you don't let it expand. Is that correct or not? Yes? Do you remember that problem in ME218? Yes? So another example of it, if you have a piece of rod, like that rod that in my hand, and it's plastic, and you have a hole exactly like that in the steel, the block of a steel, and you want to push that inside that block. You see, you push it down, it wants to expand this way, but the steel will not be expand. That means epsilon in that direction equal to 0, but it pushes against the metal, so there is a sigma there. Everybody understand that? So that's the technique. Although this is very rare to happen because the object has to be between two rigid plates to qualify with that, but still we call it plane strain, which is exactly become similar to that. Is that correct or not? Now, when we went from x and y to x prime and y prime, what equation did we get? Everybody remember that equation? No. Before we go through the Morse circle, the whole chapter 7 started like that we calculate everything based on x and what are the stresses at the direction of x prime, y prime. You remember that? Yes? Which I gave you 3 equations, etc., etc. We did that in the beginning of this class. We did it at the end of ME218. Yes or no? Then you calculated then that stresses, and you find out those stresses keep changing. Yes? When it kept changing, then it came to your mind, if it is keep changing, therefore somewhere else must be maximum. Yes or no? In order then to find the maximum, Mr. Moore gave you a routine, and that routine that all the stresses fall into a circumference of a circle. So we got the Moore circle. That's what I put there. At background, notice at the background, first page 1. Sorry. Okay. So that is epsilon x, epsilon y, epsilon z. Then this is gamma x, y, gamma, which we already gave the rotation. Then we said the state of a stress. That's the state of a stress. Then we said Moore circle. Yes or no? Correct? This is plane stress. Now I'm changing it to plane strain. Why? Because in real life, you are going to measure epsilon x, epsilon y, and the gamma, and go backward. Is that correct or not? So if this is the case, this equation, by the way, when we throw Moore circle equation, or let's not do that. Sigma x prime, for example, was equal to sigma x cosine squared theta plus sigma y sine squared theta plus 2 tau xy sine theta cosine theta. First we got that equation, then another equation for tau x prime. Then Mr. Moore turned them into a new format. Is that correct? Because he changed all the thetas to 2 theta, etc., etc. But that is equation 1. At the beginning of chapter 1 for a stress. We have to come up with similar equation. If I get exactly the same equation, I can follow exactly the same routine. Everybody understand? Let's see what happened here. In this one, this is what we are going to do. Now, this is the plane strain. I'll just put it here. I'll just briefly go over that. Let's say that here we have an object like that, which a thickness, of course, I'm not going to show the thickness. That doesn't matter. Is a plate, and then on top, and it is not deformed. Then I put here a little triangle on it. I call this one delta x, and this one delta y, and this one delta s. And everybody see that delta s is equal to delta x squared plus delta y. It could be any size, doesn't matter, on top of that plate, which is not yet loaded. Yes or no? Yes? Then I put the loading on that in this format. Sigma x, sigma y, and tau x. Do I have an epsilon x? Yes or no? If I put sigma x, sigma y, tau x, do I have an epsilon x? Here sitting in front of you. This is epsilon x, this is epsilon y, and that is gamma. Yes or no? So what happened to that shape? This is before the formation, after the formation. Please write it down. This is the same triangle. This side becomes delta x times 1 plus epsilon x. Is that correct or not? Would you buy that? Again, many people get into, I don't know why. What is the definition of epsilon x, guy? You see, that's the whole point. If you don't know the definition, I'm glad you all mentioned that. If you don't know the definition of epsilon get, then you get into trouble. None of the formula is going to help you except definition of epsilon x, definition of Poisson ratio. Everybody understand? Epsilon x is deformation per unit, 1 unit of length. Yes or no? If you have 1 inch, after deformation become 1 plus epsilon. Is that correct? So if you have 100 inch, you have to multiply it by 100. Isn't that what I'm doing here? So 1 inch, this is so simple if you go by definition. Formula-wise, I don't care. No, you shouldn't care. Definition of epsilon is the amount of deformation for 1 unit. Yes or no? 1 millimeter after deformation become 1 plus epsilon or minus epsilon, depending whether epsilon is plus or minus. Yes or no? But if I have 100 units of that, I have to multiply 100. Everybody knows that. Is that correct? Or that's the way you should set your system in order to understand this material. Don't go by formula. I did this, he did that, I'm going to follow that. Understand what you are doing. Is that correct or not? That helps you the most. Therefore, this side after deformation become 1 plus epsilon x. This side after deformation become delta y times what? Times 1 plus. Yeah, that's right. This one, because this is become delta y, because originally was delta y. Now it become, and this side, of course, this was delta s. Now after delta s become 1 plus epsilon what? If this is x prime direction, this was x direction, this y direction, this become 1 plus epsilon x prime, and we want to calculate epsilon x prime. Is that correct or not? Yes? Correct. What happened to that angle now? Why that angle is changing? Because of the tau. Because the tau causes the angular deformation. Let's ask, the angular deformation is what? The angular deformation is gamma. Yes or no? Therefore, if that was auto, this is, I'm assuming all positive. This is not always the case. This is for proof of the formula. This angle was originally was 90 degree. Now it's becoming how much? 90 plus gamma. Although gamma is very small, and we have done some of homework in ME 218 like that to calculating the value of gamma. Now, after we do that, this is the proof of equation. You don't have to go any further because the rest of it is really lengthy math. Then we write this. It says c squared equal to a squared plus b squared minus 2abc. We eliminate lots of terms, all the epsilon to the power of 2 and 3. And eventually, we come up with this equation. The goal is to calculate epsilon x prime. When we calculate all of this based on this scenario, epsilon x prime, which is the epsilon in the x prime direction, similarly 1 for the y prime, which was the idea behind the Mohr circle. Everybody understand that? So we come up epsilon x prime is equal to epsilon x cosine theta squared. Very well. We had that exactly there. Is that correct or not? Then we get plus epsilon y times sine theta squared, because this angle, by the way, this angle is theta. That angle is theta, originally was that. The theta is the shift from x to x prime. Yes or no? Is that correct or not? Yes?
What's the equation for
what?
The numbers?
This one? Or this one or this one?
No, in the triangle.
This is theta. This one?
No. Is it 90 plus something?
No, this was 90, now changes the gamma. Gamma is the angular shift of, remember we had this one, you have a new pawn like that, and you put the theta here, then suddenly become like that, and that's the gamma, yes, the angular deformation. That's what we talk in ME 218. Gamma is angular deformation, epsilon is extension. That's the big difference between the two. Everybody understand that? I hope that you do. So there is a big difference between epsilon and gamma. Epsilon is elongation or shortening, yes or no? Because it depends on the sigma, yes? Gamma is always angular deformation. You had at least 4 or 5 or 6 problems in ME 218 about the gamma. Is that correct? I don't know whether you had it or not, but I know in my classes I always have 1 or 2 or 3 or 4. Is that correct or not? We put a little neopan between. I told you about how we do the freeways, everything. Every time you have a foundation, it has to be onto something to take the vibration because you want to have that angular deformation there. Yes or no? Correct? So these are all come together. Otherwise, we cannot. Anyhow, first term is exactly what the first term. The second term, only thing that's changing, all the sigmas now becoming epsilon. Then for the last term, we get gamma xy, sine theta, cosine theta. That's what we get. Which, if you look at it, there is a slight change. Do you see that? There is no 2 there. Is that correct or not? Yes? If there was a 2 there, I could use the same idea as Mr. Mohr did, turn this into a Morse circle, but it doesn't have a 2. So what do I have to do? I have to add a 2 there. Is that correct or not? So look what happened there, guys. If I multiply here by 2 and divide that by 2, the format becomes exactly this format, yes or no? And since this later on become a Morse circle, yes or no? That also become a Morse circle, except with one difference. Sigma x become epsilon x, sigma y become epsilon, but instead of tau, I have to use gamma over 2. So write it down that unit. That's the only difference between Morse circle for a strain and Morse circle for a stress. The only difference is very parallel, everything the same, exactly the same. Everything we learn in ME 218 and 219 now applies. In other words, you have in plane, you have out of plane. All those formula is applicable, except you have to, anytime you see a tau changes to gamma over 2. For example, if I want to draw the Morse circle for this one, epsilon average, which is the center of the circle, become equal to epsilon x plus epsilon y divided by 2. I write 2 of them, not the rest. Then r equal to what? This is all in the book. You have to repeat that. Again, everything is repeat except one small change. Anytime there was a tau, change it to gamma over 2. So for example, r always was sigma x minus sigma y divided by 2. Here become epsilon x minus epsilon divided by 2. Then always was plus tau xy to the power of 2. Now tau become gamma, not even gamma, gamma over 2. That's right. So it become gamma xy over 2. Notice, just add a 2 in every equation is exactly the same. So every process is the same, every result the same. So except the minor difference that I'm going to explain that. Everybody understood that. So now if I give you a strain instead of a stress, you can do the same thing. You can come up with maximum shear strain. Is that correct? Your maximum normal strain. Where they are, in which plane they are strained are maximum, which I can put my strain gauges there. Everybody understand that? And then because this is all about the measurement. And then what is in plane and out of plane, etc. And we have learned that, so I don't have to repeat it. All I have to do is giving you an example. So this is the first example of this sort, which is very similar, very parallel, a slight modification. Everybody understand that? Now let's assume that you have put some gauges over and as part of your machine that you are designing, and you come up with this epsilon x, by the way. So write it down. I believe, I don't think this is the solution in your handout, but the problem might be there, but might be not. Nevertheless, write it down. Let's say that we measure epsilon x equal to 340 micro. Remember that we are expressing that in micro because we don't want too many zeros there. Is that correct? Micro is 10 to the power of minus 6. Let's say that we measure epsilon y, which is given to you 110 micro. And let's say that gamma xy. By the way, gamma xy is not measurable. Some of you who have been in the lab, you know what I'm talking about. We'll talk about it next class. How do we measure gamma, or how do we calculate gamma? Is that correct or not? Well, let's say for time being, gamma is given to you. Is that correct or not? I talk about gauges and how that works, etc., etc. Gamma xy also is given 180 macro radian, because this is in angle, so it's in radian. And let's say that nu is given equal to 0.3, which doesn't have a unit because nu is the Poisson ratio. Is that correct? Whatever stress or strain you are creating in one direction, nu percent goes to the other direction. Is that correct or not? Yes? Now, the question you want to answer. Question number. These are problem. First row, the half of second row is all this problem. But the first problem is the way I want you to do is this, because that's the way in the book too. In this 128, you are drawing more circle or answering the question, but use the equation only. Everybody understand that. Question number 132, and the rest of that afterward, do it always graphically. Remember the graphic format, which is much simpler than equation. That's why I'm going to do graphic here. Now, the question you want to answer is this. Calculate principal strains, which is two of them, maximum and minimum. Is that correct or not? Yes, exactly like a stress. Do calculate, find absolute maximum shear strain. Notice we have one circle, then we turn it into three circles. Everybody in plane and out of plane. We have gone through that as well. Is that correct or not? Yes? And then finally, question number 3. Let's just find. So I put it here. Find absolute maximum. Absolute maximum means you have to go not through one circle. You have to go through 3 circles. Yes or no? Some of you even disregard that in totality. Absolute maximum shear strain means there are always 3 circles, not 2 circles. The meaning is there. When I say epsilon means go out of plane. Yes or no? And find which one is the largest. Remember how you were calculating the tau? See, that's what some people actually didn't do it. When you were calculating sigma versus tau, then you come up with this circle, you draw 2 more circles, yes or no? Is that correct? That is absolute maximum. Find the radius of the larger circle, yes or no? Here is the same thing, because we have in plane and we have out of plane, so that's the question I'm asking you to do. Absolute maximum shear strain means you have to go out of plane as well and check to see which one is the largest. Is that correct or not? That we have done it. When I do it, you remember it. And finally, find strains at theta equal to 30 degree, let's say 30 degree counterclockwise. So in other words, rotate your axis 30 degree and give me a strain at that point. Is that correct or not? Yes? Let's do one by one. Started with the first one. So started with the first one. It's exactly what we do that. Of course, I can use all the equations. There are a bunch of equations in the book. You do not need to remember it. If you have to use them, I will give it to you. Is that correct or not? However, the graphic part of it, which we have practiced at the beginning in the class, it should be there. Is that correct or not? And that's what I'm going to do. Now here, we have to do this. Epsilon versus what? Before was sigma versus tau. Now it is epsilon versus, not gamma. Gamma over 2. Be careful of that. So this is automatically all the gammas become gamma. Otherwise, the circle will not work. Is that correct or not? Because my equation that I came up with has it too short there. Remember there? So as you see, if I'm looking 1 to 1, sigma x, epsilon x, sigma y, epsilon y, but tau xy must be equal to gamma over 2. In that format, then it is the Mohr circle. Is that correct or not? Otherwise, it's not a Mohr circle. Correct? There. Okay. So now we go here, epsilon x. So epsilon x is how much? 340. So 100, 200, 300, 340. Okay? Then I have to go here, gamma. The first thing you want to do in this type of problem, which is Mohr circle for a strain, by the way. Remember, this is Mohr circle for strain. Is that correct or not? First thing you want to do, because people may forget that, you want to calculate gamma over 2. Doesn't matter which plane it is. The gamma over 2 is that, this gamma is 180. Gamma over 2 is how much? Is 90, because you don't want to make it. Of course, this is based on gamma over 2. Is that correct or not? Then you go 340. This is 340. Then I have to go either up or down 90. Yes or no? Up or down. Test of your, this is the final, and you are going through the test for sigma. You should know that answer. Are we going up or are we going down, and why?
Down.
Down, correct. Everybody with me? Yes? Correct? No? Yes?
Yes.
Good. Everybody? Yes? Yes. Okay, good. So I don't have to explain it to you, correct? Now I'm going to explain it to you. Because some of you are a little bit, you are not telling me the truth. Is that correct or not? Let's find out whether you know it or not. Oh, this is what it is. This is a tau, yes or no? There is 2 methods, first of all. I'm giving you both methods. One I don't like, one I like, but choice is yours. You prefer probably the first one, because it's easy to remember. So is this a tau plus or minus? Plus. So tau plus gives you gamma plus, yes or no? Because gamma equal to tau,
doesn't matter which gamma we are talking about, divided by modulus of.
So if this is plus, this must be plus. The answer is plus, yes or no?
So if this is plus on the x for the Morse circle, is this plus or minus for the Morse circle? This was negative, this was, because this is the arrow, this is opposite to arrow, yes or no? So therefore, you should do the same thing. That's what everybody says negative, because they look at the tau. Tau gives you gamma. Gamma is the same sign as the tau. Is that correct or not? Since the other one negative, this one is negative. This is one way of looking at it. The way I want you to look at it, which is much more interesting, is the deformation. Now look what I'm telling you, which is come up with the same result. Now, look, this is going to happen. Let's put that square there. Yes or no? That square is under this kind of action. So after deformation, this becomes a rhombus because the angle changes. Yes or no? You have seen that in ME218, correct or not? It becomes like that. Yes? Look, this side went up or went down? This side moved that way, yes or no? This side moved that way, yes or no? First of all, if gamma become gamma, my fault. If 90 degree become 90 minus gamma, look, this angle is now 90 minus gamma. The gamma is positive. Is that correct or not? But look what went to the x direction. The x direction went counterclockwise, yes or no? Y direction went clockwise. Which one of it follows that one? Because that one we have here, this one. Is that correct or not? Is this plus, yes or no? Therefore, which one is plus? This one is plus. This is minus. Is that correct? So on the x is minus, on the which is the same result you achieved there. Is that correct? Because here this is minus, this is plus, this is minus, and this is plus. Is that correct or not? So that's the sign based on deformation. This is sign based on the tau. Is that correct or not? But both are going to be the same thing. Now in the negative direction, might as well I put it there too. In the negative direction, the shear is like that. The shear stress is like that. Is that correct or not? So this square after deformation, this side goes like that because gamma, this 90 degree become 90 plus gamma. But this side went this way, that side went that way. This is clockwise, therefore it is plus. This one is counterclockwise, therefore it is minus. This is minus and that is plus. Everybody understand that? That's what you said and that's exactly correct. Since this gamma is plus, so it is under this scenario, on the x is negative, on the y is positive. However else you answer me, that was correct. Is that correct? Is that what you said? Is that correct or not? Yes? Anyhow, so we go here down 90. So this is your x, which has 340 minus 90. This is epsilon, this is gamma. So that get 1 point on the circle. The other point on the circle is going with the y. On the epsilon y, I have 110. So this is 110. Obviously, this time I have to go plus 90. We have done that in the past. So we go here. So this is y, which has 110 and plus 90. And then we connect this together. This point is the center of the circle. So now let's look at this. See what happened here. This is 340, this is 110, this is the C. What's the thing? You don't need even any calculator to do that. What's this length now? Everybody with me. What's this length? 110 minus 340 is how much? Is 230, yes or no? Divided by 2 because these are similar angles. So each one become 115. Very good. So this is 115, this is 115, and this is 90. Can I calculate the R? Looking at this triangle, can I calculate the R? Notice I don't need to go to my equation. Now look where epsilon average is. Epsilon average is 110 plus 115. Is that correct? This is 110 plus 115, so it is 225. Of course, you could have achieved that by adding these 2 divided by 2. 340 and 140 is 450 divided by 2 is 225. That's the formula. This is graph. Is that correct or not? Yes? What is R equal to? Is this R? Yes or no? Yes. R equal to square root of 115 square, which is the same formula I put it there, but I'm not using the plus.
90 square, which is gamma over 2, and that one become equal to 145 macro. And then I'm going to erase part of the other board or here. So these are your sign convention. This is your question. This is the answer. And the rest of it, it follows as we have done it before. Then I put here the center of the circle. I draw the circle. Yes or no? Correct? Yeah. So let me redo that again because this way I cannot draw the circle properly. So I redraw it here. So if this happened to be my circle, this is what we did here. Again, I'm redrawing that. This is epsilon, and this is gamma over 2 with the arrow. And 1 point was here, so here was 1 point. This is not exactly the same shape, but it will do it for us. So this was the x, and this was the y. Is that correct or not? And that was the c, roughly. It has to be similar triangle, so let's put it a little bit this way. This is 115, that's 115. This is 110 point. This is 340 point. The next thing, calculating the epsilon at A and B, which are my maximum and minimum. As before, it's exactly routine. I'm saying that this is the part, this part of it is just something you already have done. Is that correct? Only modification. Be careful about the modification. And therefore, the next is calculating epsilon A and epsilon B. So this is epsilon A, which is one of the maximum principal strain, and that one is equal to, look at it, it is OC plus CA. Is that correct or not? OC is the average, which is 225, plus CA, which is the radius. The radius was 145 plus 145, so it becomes 370 macro. So this one get 370 macro and 0 because gamma is 0. Is that correct or not? Yes? Exactly like the circle for a strain. Then epsilon B become equal or minimum in this case 225 minus 144 or equal to 80 macro. Then what is maximum gamma? The maximum gamma is, of course, this point and that point, yes or no, which is the radius. Is it in plane or is it out of plane? In plane. We are in plane. Yes, but in plane. I haven't changed the circle yet. This is original circle. Irregular circle is in plane. The other two circles are out of plane. Yes or no? This is in the plane of x, y still. Correct or not? Yes. This is the whole rule. It was there. It's still here. The in plane gamma. But gamma, there we said tau equal to radius. Yes or no? But here I have to say gamma over 2 equal to radius because I'm plotting this for the half gamma, yes or no? So gamma equal to radius. So, but this is gamma, write it down. This is, if you want to write it correctly, this is gamma max divided by 2, but it is in xy plane because I haven't changed the circle yet. Is that correct or not? Yes? Correct? And that should be equal to gamma 2 over the equal to radius. Is that correct? Or equal to radius? That's again another modification. Or gamma max in plane, please write it down. In plane, xy is in plane. And still we are in the same plane. Equal to 2r or equal to 290 micro, which has increased from what we had originally. We had 180. Now it increased to 290. Yes or no? Correct? Now the next question, which is the most important question you want to answer, which I'll raise it to the other class. What is absolute maximum shear strength? What are the other two circles, in other words? You see, everybody says that sigma epsilon z must be equal to 0, correct? Maybe? Go back again to what I told you, what the plane strain. See, people get this mistake that every time that I draw the circle for a strain, it must be plane strain. Who said it is plane stress? Who said it is plane stress? If I see an object and I put a strain gauge on it, is this plane strain or plane stress? This side. Plane stress, yes or no? So I did not define that for you purposely. So you have to tell yourself, was this a Oreo cookie? Everybody understand what I'm saying that? Was this object between two rigid plates or not? Which some of you were thinking that's the case. Is that correct? Because that's the way the formula was started. However, let me explain to you. All of that coming to in a minute. Everybody understand what I'm doing? This is in plane, yes? I'm looking for out of plane. There is two scenarios here. One of them is very common. The other one is very uncommon. Is that correct or very rare to get to that? Is that correct? The one very rare is between two rigid. So you have only one or two problems like that. Is that correct or not? And in real life, the same thing. If you are pulling a plastic into a rigid concrete hole, then that is a plane strain. Everybody understand it. When you are designing a beam, a column, surface of the car, surface of airplane, in this surface, is it exposed to the air? Yes or no? It's going to, so it is, everything is plane stress. Everybody understand it. Reverse of the other one. So I want you to understand that. If the problem is stated, this is a plane strain, then you say, okay, if this is a plane strain, epsilon z must be equal to 0, as you were thinking of. Is that correct or not? But that is a rare scenario. Everybody understand that. That is happening. That's what it's reverse of the other one. The other one, always sigma z was equal to 0 until I put it underwater, which was very rare. Everybody understand that. Here is reverse. If I put my object between two rigid bodies, then it becomes plane strain. Everybody understand it? And all the objects are free to move. Yes or no? Every object that you see, it is free to move in the z direction. Accept or not? So this is the rare one. Yes or no? But put it there. If epsilon z equal to 0, then this would be epsilon z. Is that correct or not? Then the other two circles, one will be here, so I'm going to put it there. And one will be there. Is that correct or not? As you were expecting it, but this is plane strain scenario, correct? So in this plane strain scenario, which is epsilon is 0, then we get this. Then we get what? Then we get this larger circle, so gamma max over 2 will be in which plane? It is x, y, and z, so it will be this circle, yes, which is between x and z, that's right, which is out of plane and equal to 1/2 of epsilon max, which is 370, minus 0. Is that correct or not? Yes? And 2 and 2 drops out. So gamma max in xz plane, now which is out of plane, become the diameter, not the radius of macro, and that is out of plane. If our system was plane strain, means in the z direction, no movement. Is that correct or not? Yes? Which means the object should have not moved in the z direction. Get one of those homework in ME 218. Take this plate, push it this way, push it this way, push it this way, push it, but put this side on the rigid plane and assume this is z direction. Is that correct or not? Then it becomes a plane strain. Everybody understand what I'm. However, if you look at this book or any plate here, this board, pull it this way, pull it this way, push it this way, that will expose this way. Is that correct? Then it becomes plane strain. Yes or no? So although I'm drawing this, granted, this is in the case. Did you write it down? Yes or no? No, I'm writing because I'm running out of board. I'm writing this in plane stress scenario, which is all your homework problem from day first to now. Is that correct or not? Yes? Is epsilon z equal to 0? No. How do we calculate that? From those equations of Hooke's law. Everybody understand what I'm saying that? Yes? So I'm going to give you the equation. Now, in plane stress scenario, since we know epsilon c equal to epsilon z is not equal to 0, as we stated at the beginning, we have to calculate that. It is obvious. Look at it this way, guys. If this is a plate, although in my telephone, if I'm pushing it this way and pushing it this way, this side is going to get bigger. Or if I'm pulling it and pulling it, this side should be get small. It's obvious, so it's plane stress because it's exposed. Is that correct? But if this is between two rigid plates, then it's plane strain. Everybody says, which is very rare. So plane strain is rare. Plane stress is normal case. Is that correct or not? However, since this is the case, this is what we have. Epsilon x was equal to, please write it down, sigma x over E minus nu sigma y over E. But I have there, though I erase it, so I have to rewrite it again. Epsilon y was equal to minus nu sigma x over E plus sigma y over E. This is the general rule. Now I have epsilon x and epsilon y was given to me. Epsilon x is how much? Epsilon x is 340. Epsilon y is how much? Whatever I give you, 110, is that correct? I give you the nu, I give you modulus of elasticity, then you can calculate sigma x and sigma y. This is the general rule. And then you put it in this equation. Some people forget about the equation I'm going to give you. So epsilon z equal to minus nu sigma x over E minus nu sigma y over. This is the general rule. If I don't give you any equation, this is what you do. You take, this is two equation for two unknown. By the way, you have to use that in some of your homework. Write it down in front of you. Two equations for two unknowns, and those two unknowns are sigma x and sigma y. Sigma x and sigma y. You calculate sigma x, you can calculate, you can answer that question, and then put it here, calculate epsilon z. So if these two are compression, this one become larger, or vice versa. Is that correct or not? Okay. However, I'm going to do that for you in the very short manner because I'm running out of time, so I want to show you something very important. This is how we do it without doing that. We multiply that equation by nu, everybody under the entire equation. Then we add these two together. Everybody see that? Then sigma x is going to be eliminated. Then we want sigma y, and then we put it back. Eventually, we get this equation. This is the result of eliminating sigma x and sigma y between these two equations and plugging in here in general gives you this equation. Epsilon z equal to epsilon c equal to minus nu over 1 minus nu epsilon x plus epsilon y. So put that one in your equation. That's the result of that operation. So if you don't want to go through operation, which is lengthy, use that equation for epsilon c. As you see, if this is positive, this one become negative. Pulling, the other side become negative, smaller. If this is negative and negative, obviously the other side becomes, you pushing and pushing, the other side become larger. So let me finish the problem, then you can ask now. For our problem, what's epsilon c equal to? Now let's solve it. Epsilon c become equal to what's the value of the nu? Notice E was eliminated here. Actually, E drops out because E has nothing to do with it. What is epsilon? That was plane strain. Everybody has stress. And now I'm doing plane stress, correct or not? Then I need to calculate epsilon c. Is that correct? Because epsilon c is in plane stress is not equal to 0. What was the number I gave you? Minus nu, minus 0.3 divided by minus 0.3 multiplied by what? By epsilon x. Epsilon x is how much? 340 plus 110. By the way, this is applied not to x and y. It applied, I don't know, some of you may want, applied to a and b, applied to any x prime and y prime. Everybody understand that? Because it doesn't matter. When you change this to another location, I want you to understand what is here. I mentioned it for other class. Look, 340 plus 110, how much is that? That is 450, yes? Look at epsilon A and epsilon B. Where was epsilon B? I erased it. What was epsilon B? You calculate. What's epsilon B? It's 370, and this is 80. So how much is that? 450. That's always constant. Everybody understands. So it doesn't matter whether you use it for X and Y or use it for A and B or use it for any 2 points. It's always the same. Is that correct? Because the sum is the diameter is constant. When you add to something A amount, the other one reduces by A amount. Do you see what I'm talking about? So this formula, you can use it for X and Y or use it A and B. A and B being this and that. Is that correct? The same result achieved, if that was your question. But let me finish this one. This one becomes minus 190 micro, which is acceptable because this is in tension. This is in tension. Epsilon C must be in shortening mode. Is that correct or not? Yes? So therefore, this will be your tree circle. Sorry, I have to go to the quiz, but I have also something else to show you, but I don't have time. I'll do it next time. So therefore, this is your circle again. This is what happened here. This is your circle. This is 370. This is 80. So where is epsilon z is not equal to 0. Epsilon z in general always is a number. Tension, and tension gives you this one, shortening. Yes or no? How much shortening? Minus 193. That's right. Minus 193. Then you put another circle here. You put another circle here. This is the larger circle again. The larger circle is between x and z, but this one is plane stress. So therefore, gamma max become equal to 2r in xz plane, which is actually equal to 370 minus 103. No, remember, there was a, in order not to, there was 1/2 here and 1/2 here. Let's put it this way. This was gamma over 2, 1/2 or 1/2 on 1/2 drops out. So it become equal to minus, or become equal to 500 something, I don't know. You can calculate that. 5?
630.
Yeah, okay. So let me put it, I have it here, 500. 60? 60, okay. Accept that, 560. I want to double check that. That's your responsibility. Anyhow, I would give you the result of that one next time on the picture format. So, and from then, but you need to do your first 4 or 5 homework to get into this. Do a little bit of studying about chapter 1, this relationship gamma, because from now on we are going to do some fancy problem that requires all your knowledge of static and strength of material, and this one. This Mohr circle part of it is very simple. The equation that, look at some of the homework I have given you in the handout. In order to understand that, you have to go back again to the background and study everything you want to know about gamma and epsilon and Poisson ratio.